in chapter 6, section 5, last video we talked about uh, exponential growth. Now we're going to talk about exponential decay. And one of the main things that talks about exponential decay is radioactivity. So any radioactive substance is going to decay over time. And so that decay over time uh, is proportional to the amount that we start with. So the mass that we start with is proportional to the rate of decrease over time. So that is the same thing as, so you can write it like this. The mass, the rate at which the decrease of mass over time is equal to, it's proportional to, so K times the original amount. So this is very much like the population and the rate of growth. Right, so it's the same equation. So that means we can write it using that one theorem. We can find our population given that our original mass sub 0, times e raised to the kt. So we can use this to find our amount of mass. And this gives us the idea to the half-life. So every radioactive substance will decay over time, and the time that it takes to decay to half as much as it started with is called a half-life. So that's the idea of a half-life, and you've probably seen it before in chemistry, trying to figure out how long it might take to equal out to one size compared to another. So we're going to work through a problem that deals with half-life. And so we're going to look at the half-life of radium-226. And that half-life is 1,590 years. So that means if I start with 100 grams or 100 milligrams, some kind of quantity, it's going to take 1,590 years of radium-226 to decay to half that amount. Okay, so this first one, we're going to come with a sample of 100 milligrams of this radium-226, and we want to find the formula to find the mass. So because this is proportional, the mass is proportional to the rate of decay, so not rate of growth, but rate of decay, we can use this formula, or this is our original amount, m sub 0, e to the kt. So first, we have to find out what this k is, and that's why they give us this kind of example of given as the original amount. So there's our 100 here, and they don't give us a k. So we want to find out what k is. Well, we know that it takes 1,590 years in order for it to decrease. So we're going to use that number as our years to get some more room here. So we're going to use that number of our years, 1,590, and we know after that many years that this amount of 100 is going to decrease to half, right? And so we can divide both sides by 100. We get 1/2. That's where it comes, half-life. Get a half of the mass. And now we're just solving this exponential by taking the log of both sides. So ln of 1/2 is equal to, if I take the ln of this, I'm just going to get k times 1,590 and divide by 1,590. So this will give me my relative decay rate, my k. So I type that in, and my k turns out to be, I could leave this in there and that'd be more accurate. That's the exact value. Or I can go ahead and round my number. But if I leave that in there, it'd be more accurate. So let's go ahead and leave that in there. So ln of 1/2 over 1,590 times t. Okay. So there's my formula for the mass, to find the mass of radium-226 after so many years. All right, so now it wants us to find the mass after 1,000 years. So now I can enter in that 1,000 for my years. ln of 1/2 divided by 1590, and then I'm going to times that by 1,000. Okay, so I can enter that in my calculator. Just have to make sure my parentheses and stuff like that is correct, and we get 65 milligrams. That's how much is left. Now we can figure out, okay, how long will it take to get to 30? So this is a little bit more work because now that's how much mass we want out the end. So that's our M at the end. This is 100. We have this 1/2 divided by 1590, and then times by t. So again, we want to solve by t. So I need some more room here. So we divide both sides by 100, we get 30 over 100. Or we can cross out those zeros, 3 over 10. ln of all this stuff. Then divided by 1590. So I'm taking the ln of this first and then divided by 1590 and then timesing by t. Right? So now we take the ln of both sides. And so we can take ln of 0.3. Need some more room here. Take the ln of this side, I'm just going to get this, right? When I take the ln of that. So ln of 1/2 divided by 1590 times t. So then I'm going to multiply both sides by 1590. And divide by ln of 1/2. Go ahead and finish this part. Take that, divide it by the ln of 1/2, and then times it by 1590. That will give us our t, which is 2762, which seems about right because it should be more than the 1590, right? Because 30 grams is more than half. So there's our answer.